Hello everyone. Today we're delving into the world of electronics with our project on understanding and building a power source. This project will help us grasp the fundamentals of how power sources work and how to construct one from scratch.
What's a power source and its function? A power source is an essential component in electronics that provides electrical energy to a circuit. It converts input voltage to the desired output voltage, required for various electronic devices to operate efficiently. Components of a power source: MOSFET LM317. The LM317 MOSFET is a voltage regulator that adjusts and stabilizes the output voltage, and it operates by controlling the current flow between the input and output terminals, thereby regulating the voltage to a specific level. MOSFET LM7805. The LM7805 MOSFET is another type of voltage regulator that ensures and constant 5 volts output in functions similar to the LM317, but is specifically designed to provide a fixed voltage output of 5 volts. Bridge rectifier. The bridge rectifier converts alternating current to direct current. It consists of diodes arranged in a bridge configuration, allowing current to flow in one direction only, thus producing a smoother DC output. LED and resistors. A LED indicates the status of the circuit. It lights up when the power is applied, serving a visual indicator. Resistors: 300, 2300, and 2017 limit the current to the LED, protecting it from the excess current and ensuring the longevity. Fuses and capacitors. A fuse of 1 ampere protects the circuit for overcurrent conditions, preventing the damage of the components in case of a fault. Capacitors stabilize voltage fluctuations, filter noise from the from the power supply, and ensure the smooth operation of the circuit. Transformer. The transformer steps down from the input voltage from 24 volts from alternative current to a lower alternative current voltage suitable for our circuit. It plays crucial role in reducing voltage levels before further processing by another components.
Diagram of the power source circuit. This diagram illustrates how all components are interconnected in our power source circuit. Each component's placement and connection are crucial to achieving a functional power source. Process of constructing the power source. Now let's walk through the steps to build our power source. Step 1. Gather all necessary components as listed early. Step 2. Solder the components onto a perforated board according to the diagram circuit. Step 3. Ensure all connections are secure and insulated to prevent short circuits. Step 4 and finally, double check the assembly against the diagram to verify accuracy. Verification of power source functionality. After assembling the circuit, it's time to verify its functionality. Step 1. Connect the power source to an appropriate input voltage source. Step 2. Use a voltmeter to measure the output voltage across specified points. Step 3. Check the LED for illumination indicating power flow. Step 4. Ensure the voltage remains stable and within expected parameters.
In conclusion, building a power source involves understanding each component roles, and how they interact to produce a reliable output with time. Throughout this project, we have learned valuable skills in circuit assembly, testing procedures, and troubleshooting. We've covered the fundamentals of power source, explored its components, function, and successfully constructed and tested our one power source circuit. This project not only enhances our understanding of electronics but also prepares us for future endeavors in electrical engineering.